So the idea here is that this is like biometrics. In particular, the definition is to derive knowledge from the analysis of human physiological data. And in particular today, just this, kind of exploring that idea just a bit further in terms of how that might be applied to enhance our design abilities. Let's see if I can. Yeah, okay, so here we've got the potential of it. So it's related to humans and computers. Many of us use computers in our work. And so this idea that biometrics can lead to improved computer user interface, this idea that I'll introduce this idea of the direct emotional and motivational state feedback, and then finally this promise of cross-cultural communication reach of our design efforts. So when it comes to design, the perception of it is much like perception of environment. So, and all perception is stimulus, and all stimulus results in physiological response. So, and then physiological response is linked to our motivational state and our emotional state. So here's an example. So right now I'm somewhat like a little neutral facial expression, but if I smiled like that, so this muscle right here is called zygomaticus. And so that's kind of a pleasantness sensor. So if I could put electrodes there and measure that contraction, I could get an indication of how pleasant something was. And to the point of actually seeing a smile even before it manifests on the face, that kind of pleasantness proto-sensor or something. Mm-hmm. And then there's another one called corrugator here. I'm frowning, this kind of corrugator, this muscle up here, same thing, but it's the opposite. It's an unpleasantness sensor. So there's simple examples of how those things might be measured. So there's a whole bunch of people, obviously, we could quote here about have done work in physiological, emotional, motivational states. So just to kind of pluck four that really connect with me. And starting with Hume, David Hume in 1740, he wrote this document, it's like a little pamphlet called A Treatise on Human Nature. And Hume was talking about this idea that our cognitive state, our kind of rational thought, sits on like an emotional sea. And so he phrased the term as reason is not only to be a slave of passions, this kind of idea that we're driven very much by our emotional state, and our cognitive state is like kind of sitting sort of gently on that sort of sea. And James, he spoke specifically to the subject of emotion, and it's still unclear exactly what an emotion is, but James thought that it was kind of story that we make up about a physiological response that we're experiencing in our body. So we have something happens, there's some stimulus in the environment, we have a response to that, and our kind of naming of that response that we're feeling is the emotion. Levinson, in 1982, he looked at Stanford college students and the Minangkabau of West Sumatra, two very kind of different groups of people, and subjected them to certain kinds of stimuli. And he found that there was very strong consistency in physiological expression between these groups. And so this speaks to this idea of a physiological state, if it was something that we could give a kind of clearer language to. It's something that sits below culture and sits below our upbringing and our opinions and all that. And then finally, Blaskovich, he got into something else completely, which is this idea of kind of an adjunct state that sort of sits maybe orthogonally to emotional or motivational state in people, and he called it motivational state. He called it a correlational theme, and this idea that when we go through our lives, that whenever we encounter something that has some impact on us, it's a kind of a significant event, that we either regard it as either being a challenge or a threat. So when it comes to human biometrics, there's different kinds of physiological data. There's biometrics that point to emotional dimension, and then biometrics that point to motivational state. So here's the circumplex model of affect. This is worked in the 80s, and so some human emotions are plotted here. And so pleasure, the zygomaticus, would be an indicator, pleasure indicator. You have displeasure indicated by maybe corrugator, and then deactivated states would be like decreased heart rate or electrodermal activity, and then activated states would be like increased heart rate, EDA or respiratory rate. And when it comes to motivational states, it also can be indexed by physiological variables. So in terms of the core relational themes of challenge and threat, if you have like a little or no change in blood pressure and like an increase in stroke volume, which is the amount of blood that your heart pumps with each beat, and a drop in vascular resistance, that's a challenge state. And that's like an aerobic response to a circumstance. And then a threat state would be an increase in blood pressure and little or no change in stroke volume and a small, perhaps small increase in vascular resistance. So when it comes to design, like this is kind of a lot of people, we do this in our work. And so we talk to a computer, that's that yellow box at the bottom, and then we sense what the computer is telling us, and the design effort perhaps is relayed on the computer through either the computer monitor or the speakers. We have some emotional, motivational cognitive response. There's David Hume sitting on top of that, telling us about our rational guidance. We form an idea, and then we have some physiological control, and then we manipulate the design on the human-computer interface and make this like looping kind of thing. And so, and it goes in this counterclockwise direction. And so what if, instead of this, instead of having this sort of like sort of loop where you have this rational thought that's guiding the mouse and the keyboard here, what if there was something like this, where you have a kind of relationship with the computer and you have like an emotional, motivational state resonance loop with the computer. And so the computer is aware of your physiological state, your motivational state, and can iterate the design in some kind of like high-speed way, and that's below thought, and below rational guidance, and below all that stuff. And then you're in this loop, and then all of a sudden you say, okay, I'm done. The computer recognizes that you're now in a different emotional state with respect to it. It kicks you out of it and says, would you like to go back to your normal mode? And so this is not science fiction. This is like how it is. This is an example here. Hopefully I can get this to work. I don't know. It's looking terminal. Oh, wait, here we go. Oh, okay, here we go. Okay. Okay, so this is a BCI. This is a brain-computer interface. And you see this kind of scrolling of these numbers. Let's see what I'll try to do. Maybe I turned it off. So what happens is that this person is communicating with this computer through what's happening in their brain. And this is exactly what this is. This is occurring below thought and below. This process is occurring within about 300 milliseconds. And so let's move along here. Help. How do I? Okay, great, awesome, next one. Okay, yeah, so here's examples of other kinds of systems that are computers responding emotionally. MIT robot, a mobile dexterous social robot. This is a Babbage cabbage, which is kind of like a whole other story. But it's a kind of empathic living media. And see, so once again, this one, oh yeah. Okay, and so this is kind of like that idea extended to the designer loop, but extended to the recipient. So kind of like you could create this sort of fabrication between all these, between like designer and recipient, and kind of construct a emotional motivational resonance loop there too. This is an example of that kind of from the political framework. Back in 2008, we were involved in some work that had the designer, the politician, and they were measuring motivational and emotional responses, and then crafting, the potential is there to kind of craft a message that would be delivered differently depending on how people were physiologically responding to it. So this is what's possible now, these items here. Here's one conceptual example that's kind of interesting. It's kind of idea of like as an architect, and you're bringing somebody through a virtuality, and it's either real or virtual. And so you're monitoring valence, you're monitoring arousal, you're monitoring motivational state, and the person encounters this like hallway of yellow doors, and there's a drop in valence, and there's a drop in motivational state. And so then the question is you see these things happen, and they're lined up, and they're correlated with the virtuality or the real experience, and then the question is, what do you do about it? So how to get this data? Like these are one ways. This is kind of like all kind of wired connections, sort of wireless and logging connections, functional neuroinferred imaging, and then this is new work out of MIT, vital radio and Eulerian imaging to get this kind of data non-contact, and some new efforts. And then this is work by Philippe Baluc, Aura, which is lovely, which I won't show you, which is kind of thermal imaging of people, and then finally, and this is actually something I'm not sure you can see there because Antonio touched on this, which is this idea of like dance and then how physiological expression can be used to surround the dancer with the dancer's own kind of movement, but reflected as sound. So anyway, thank you.